190 light-years from Earth. There is a star that once measured older than the universe itself, 16 billion years old by the first estimate, 2 billion years older than everything, including the space it floats in. The measurement was refined, and the paradox faded, but it left behind an uncomfortable question, and in the last few years, that question has returned through the most powerful telescope ever built. The age of the universe is one of the most precisely measured numbers in science. In 2018, the Planck mission, a European space telescope that spent years reading the oldest light in existence, delivered what looked like the final word, 13.8 billion years, give or take only about 20 million. That is precision of roughly 1 part in 700. On the largest question there is. The number anchors every textbook on Earth, and yet in 2023, a peer-reviewed paper argued that it might be wrong. Not wrong by a rounding error, wrong by a factor of 2. No one has ever watched the universe grow up. Its age is not read off a clock, it is calculated. The universe is expanding, with galaxies drifting apart like raisins in rising dough, and running that expansion backwards like a film in reverse, leads to a single dense beginning hotter than anything since. How long the rewind takes depends on the recipe. How much matter, how much dark energy, how fast space stretches. Change the recipe, and the age changes with it. The star in the constellation Libra was an early warning. Nicknamed the Methuselah Star, it seemed to break the timeline until better distance measurements pulled its age down to somewhere around 12 to 14 billion years. Old but no longer impossible. The timeline survived. Then, in 2022, the James Webb Space Telescope started sending pictures. But here is the fact that stops most people cold. Webb found galaxies shining from a time when the universe was barely 2% of its current age. The current record holder was already shining 280 million years after the beginning. If the universe were a 50-year-old adult, that galaxy lit up when the cosmos was barely 1 year old. And some of the early objects looked far too heavy. In February 2023, a team led by astronomer Evolab reported 6 candidate galaxies, so massive, so early, that the press started calling them the impossible galaxies. A newborn universe does not build grown-up galaxies. Either the pictures were being misread, or the timeline itself was. But here is where it gets strange. In July 2023, Rajendra Gupta, a physicist at the University of Ottawa, published a paper in one of astronomy's oldest journals with a proposal most scientists had considered unthinkable. The universe is not 13.8 billion years old. It is 26.7 billion, nearly twice the accepted age. Gupta's model rests on 2 ideas science had already exiled once. The first is tired light, the suggestion. First floated in 1929, that light simply loses energy on its long journey across space, reddening with distance the way a runner fades over miles. The second allows the constants of nature, the fixed numbers that set how atoms bind and how light moves, to drift slowly across cosmic time, blend both with ordinary expansion, and the same sky can be read a different way. The rewind runs longer. The universe doubles in age, and the impossible galaxies stop being impossible because they suddenly have billions of extra years to grow. Most cosmologists are not persuaded, and their reasons are concrete. Distant supernovae visibly run slow. A survey of about 1,500 exploding stars showed that at great distances their light curves stretch out almost exactly as an expanding universe predicts, like clocks ticking at half speed when seen from Earth. Pure tired light predicts no such slowing, which is why the idea spent 90 years in exile. Gupta argues his hybrid version accounts for the stretching, and independent teams are still testing that claim against the oldest light and the layout of galaxies. Meanwhile, the impossible galaxies themselves began to deflate. Sharper measurements cut many of the mass estimates down, and many of the strangest objects, the little red dots, now look less like monstrous seas of stars and more like young galaxies lit from within by feeding black holes, though that debate is not finished either. The emergency that inspired the doubling has mostly dissolved. The doubling itself has not been settled by the data. It has been published, contested, and left on the table where it remains. And if it ever moves off that table, it takes far more than a birthday with it. The stakes reach far beyond a number in a textbook. The age of the universe is the frame every other story hangs on. How long the first stars had to forge the carbon and iron that living things are made of. How quickly galaxies can assemble. How much time life on at least one small planet needed to appear. Double the age, and every chapter gets rewritten. In Gupta's version, even dark matter, the invisible scaffolding thought to hold galaxies together, becomes unnecessary and simply vanishes from the books. And now, here is what is new. Even mainstream cosmology has stopped treating the number as untouchable. For years, the two best methods for clocking the expansion of space have kept returning different speeds. A standing disagreement known as the Hubble tension, and every proposed cure nudges the age of the universe one way or the other. The Dark Energy Spectroscopic Instrument, reading the sky from a mountaintop in Arizona, keeps finding hints that dark energy, the push driving expansion ever faster, may be weakening over time. If that holds, the universe is about 119 million years younger than the textbook figure. A small correction, but a correction proof that the most famous number in science is a conclusion, not an observation. And conclusions can move. The next few years will squeeze the question hard. The instrument in Arizona completed its planned 5-year survey in April 2026, mapping 47 million galaxies and quasars into the largest three-dimensional chart of the universe ever built, and has been extended into 2028, with its next major data release expected in late 2026. Europe's Euclid telescope is surveying billions of galaxies across a third of the sky, with its first full cosmology results expected no earlier than mid-2027. And NASA's Nancy Grace Roman Space Telescope, fully assembled and in final testing, is scheduled to launch as soon as late 2026 to chart how cosmic structure grew across time. Each of these maps is a stress test. If the constants of nature drift, if light tires, if dark energy fades, the distortions will be written across billions of galaxies, far too many to hide. The instruments that could vindicate the doubling or bury it for good are already pointed at the sky. Somewhere beneath all the models sits a true number, the actual span between the first moment and this one. For most of history, humanity could not even ask the question honestly. Now there are machines in the sky measuring it from 3 directions at once, and within a decade the answer will be sharper than it has ever been. Maybe it confirms the textbooks. Maybe it moves. Either way, the universe has been keeping its own time since before the first star lit, and we have only just learned to read the clock. Keep looking up.